Everyone is talking about AI agents. It's hard to escape videos on your feed hyping up the latest Claude Code feature or telling you why the latest tool is going to completely change your workflow. But what might surprise you is that building an AI coding agent is actually much simpler than you might think. So in this video, I'm going to show you step-by-step how to build an AI coding agent completely from scratch. I'm going to show you my entire development process, step-by-step, including all of the mistakes I make along the way. What's really interesting is that by the end of the video, we'll have an AI coding agent that can actually write and review its own code. If you want to follow along, I'll link all of the code and the documentation in the description below. You're welcome to download it and check it out. So the code you see here was written entirely by the coding agent that we're going to be building today together. What's really, really cool about this is the coding agent we built is fully functional, is able to write code, is able to run bash commands, and is able to act as a miniature Claude Code. And we're going to build this in a short amount of time. Okay, and so the agent loop is the core of this whole thing. And it's worth understanding this because basically everything else in the coding agent is built around this really, really simple loop. Although the code looks pretty complex here, what's actually happening is really, really simple. So when we send a message to a coding agent, we send our message, which would be the task here. We send that to an LLM. So we call an LLM with that message. And then if the LLM wants to invoke a tool, we will basically invoke that tool. So you can see here, if the reason to stop is tool use, what we do is we invoke the tool and then we send the response back to the LLM so that it can see the response from the tool call. And then we just do this in a loop until we get to a point where the agent does not want to call tools anymore. That's basically all we're doing here, and it's a really, really simple loop. And then one other doc I want to point you to is this idea of the event loop. So this was the most interesting thing I found when using or researching into Claude Code. So I've built these kind of coding agents before many times, but I hadn't used this particular event pattern. So essentially what happens is within the agent loop, we emit various events, and then outside of that event loop, we can listen for things that are happening and then respond. This whole pattern allows us to keep things really, really clean inside our agent loop. So rather than writing a bunch of logic inside our agent loop, we can just emit events and let all of the other logic kind of happen outside of that through listeners. So this is a pretty standard pattern in software engineering, but it's really, really powerful here for coding agents. And this is basically how Claude Code hooks work. So when the agent does something like calling a tool, it will emit an event, and then you can hook into that event. And all of the logic actually here is based off these events. So logging, for example, checking for permissions would be a good example. You can listen for a tool call, and then you can have a check to see if the tool call needs permission approval. Things like that. So it's a really powerful pattern. I think this was the most interesting thing that I learned while building this. We're also going to add subagents to this. This is a relatively simple concept. So the idea of a subagent is the agent will have a tool that allows it to spin up another agent. These agents will be given a context or some information. They will run in the background, and then they will pass that back to the primary agent. We can run multiple agents in parallel. So that's one of the goals here, that we can support subagents because it's a really useful feature in these coding tools. All right, so now we're in Visual Studio Code. The first thing I want to do is create a folder for the high-level spec. So I'm going to create a docs directory, and let's create a file here. So plan.md. I'm basically just going to brain dump a load of ideas around what this is going to be, kind of just brain dump some of the features. And then the idea is we're going to take that and turn it into a requirements doc. So before we start coding, we want to figure out what the requirements are for this particular agent. So we're building a terminal-based minimal coding agent. It runs in a terminal. We're going to build this using Python and the Anthropic API. This is going to be a mini version of a tool like Claude Code. A user will be able to start it in the terminal, and the agent will be able to perform actions such as reading and writing files and editing files, and it will also have the ability to execute bash commands. The primary user of this is a developer who is learning how to build coding agents from scratch. So we want to keep the initial build relatively simple. We also want a basic UI. So we want a nice looking terminal UI, maybe with the rich library from Python. We won't do any streaming, but we do want the ability to see the agent's thinking trace. So when the agent is thinking, we want to be able to see that in the terminal. And we also want to be able to see the tool calls that are being made. This is really important because we need to make sure that we can see which tools are being called. All right, that's pretty much it, I think. Let's start there and see what we get to. So I've just dumped all of that into a text editor. And so what I'm going to do now is open up Claude. So let's close this window. Let's spin up Claude and let's take this plan and turn it into maybe a requirements doc and make sure we've got the requirements locked in. So I'm going to use a custom / command I have here, which is going to essentially build a requirements doc. And I'll link all of these commands and references in the description below so you can get access to them. So we're going to create a requirements doc, and I'm just going to pass in the let's say at docs/plan. So I'm basically giving Claude the plan, and I've got a prompt here that says read the plan and turn that into a more structured requirements doc that we can then go and edit. So as you can see, it's figuring out the MVP. Okay, so before we go on, it looks like Claude has asked us some clarifying questions. So is the MVP just a call loop? So user prompt, agent thinks, tool calls, or do you want conversation history? Okay, so this should be good. I think we've got a lot of good stuff here. So Claude asked a bunch of really good clarifying questions. So now hopefully when it writes the requirements doc, it's going to be a lot better than my initial brain dump. All right, so let's go ahead and create this requirements doc. You can see here now we have a document here, which is just listing out kind of the notes we had. It's a much more detailed requirements doc. You can see here the primary user is a developer using to build coding agents from scratch. We've got a bunch of functional requirements. It runs in the CLI, natural language input from the user in a REPL style loop. This sounds good. The agent maintains conversation history across turns. The agent uses the Anthropic API with extended thinking. This is important because you need to enable this in the API for this to work. The agent can read file content, list directory contents. The terminal UI uses the rich library to render formatted output. The agent does not use streaming. This is an important thing. We're going to keep it really, really simple. We're just going to wait and we're going to have some kind of spinner in the UI, a little bit like Claude Code, and then non-functional, well-written code that's easy to understand, and we can install it via UV. This seems pretty good. I'm going to remove this total source code under 1,000 lines. I think this is risky because it might dictate too much about the implementation. I don't really mind how many lines of code this is. So I think basically we have what we need now to move on to the next phase, which is going to be taking our requirements doc and then building a technical plan, which is going to describe how we're actually going to go and build this. So I'm going to run another command. So I'm going to type blueprint architecture. So we're building an architecture document. So blueprint architecture. And then I'm going to pass in the requirements doc. So that should be good. So these commands, basically what they do is they take documents and then they generate other documents. So in this example, we're taking the requirements and then we're turning that into a technical design. And the technical design is going to guide how we go and build the project. So the technical design is really, really important, and it's how you would build a project in a typical development cycle. Okay, so it looks like we now have the architecture doc. We've also made a couple of updates to the requirements. Let's take a look. So synchronous single process. The thing we missed here, I think, is the ability to have sub-agents. That was one of the goals I wanted for this MVP. So I think we need to go and fix that. So the agent should have a tool that allows it to spawn sub-agents. It can spawn multiple sub-agents that can run in parallel, and we can use async IO in Python to run these in parallel. All right, so let's go ahead and make that change because we do want sub-agents. I think it's a really great feature to demonstrate. Okay, so let's go ahead and approve that change to the requirements. So we're adding sub-agents. And I think one other thing I want to add here is when I was doing the research, one of the most interesting things I found about agents like Claude Code is the design pattern around event loops, essentially. So Claude Code has a bunch of hooks that allow you to hook into various parts of the lifecycle, and we want to follow that pattern when we're building this agent as well. It keeps the code really, really clean, and we can basically attach listeners to certain events, like when the agent calls a tool call, or when the agent performs any particular action, we can respond to those actions via an event loop. So that's going to be one of the more interesting parts of this, write a single line of code. So one of the interesting things about this workflow is obviously we're spending a lot of time building documentation and requirements, but this is really going to help us later on. When we come to do a task breakdown, we're going to have a really clear set of requirements that are going to allow us to easily give things to a coding agent, and we're not going to miss anything obvious. We're going to reduce the amount of iteration later on by being really clear about what we want up front. Okay, so now we've updated the requirements doc, but there's one other thing we missed here, and that's the idea of the event loop. So essentially within Claude Code, we have an event loop, and the agent will emit events at certain points in its lifecycle. So when it calls a tool, or when it finishes calling a tool, the agent is then going to emit an event, and we're going to respond to that. That was one of the most interesting design patterns that I found researching into Claude Code. So I'm going to try and add this into both our requirements and our architecture, because I think it's one of the most critical and interesting parts of this entire build. Just in case you're interested, the commands we're running here to generate all of the various files are just a set of prompts, essentially. So this is a repo I created recently, and it's just mapping out the traditional software development lifecycle. So we come up with requirements, we build a technical design, we break the technical design into a bunch of tickets that we can give to an agent, hand off the work to an agent, and then obviously we do the normal Git workflow as well. So this is a really simple way to think about spec-driven development. And inside here, you can see a bunch of commands. So we have the requirements command, which is just a skill. And the idea here is we transform rough notes into structured requirements. We can use this when we're starting a new feature. And we just kind of have a basic, prompt here. You're a technical product manager. Your job is to essentially generate requirements. And then we've got a template of roughly what we want. I don't think you need to make this particularly complicated. The agents are pretty much smart enough to do a good job with minimal prompting, in my opinion. And then we can also take a look at the architecture skill as well. So the architecture skill will take a requirements document, and it will generate, a high-level architecture of what we're doing, the system design, break down all of the components. This is kind of what an engineer would do, typically in a architecture doc in any other company. So it's pretty simple structure. Again, you're welcome to copy this, but there's no magic here. This is just a prompt that helps us generate an architecture doc. All right, so going back to the architecture, let's go and take a look. So if we take a look here, we should be able to see, so we've got an event-driven agent loop pattern. The agent loop is deliberately kept pure, contains zero UI approval or logging logic. Yeah, that's exactly what we want. All side effects are handled by event listeners. Again, this is a really key part of Claude Code. And if you think about Claude Code hooks, essentially what happens is the agent emits an event and then you hook into that event. So this is exactly the same pattern we're building here. So the architecture separates the agent loop from the LLM provider. This all looks good. Let's drag this out a bit so you can see. So we have our CLI, which we run in the terminal. We have the agent loop, which is just basically a very, very simple basic agent loop. We have our tools. So we've got read file, write file, find files, list directory, run bash, spawn agent, which we can spawn sub-agents. That looks good. Let's take a look to see if there's anything else you want to change. So we've got the core agent loop. We've got the event bus, and we've got a thinking event, tool call event, tool result event, response event, error event, tool call event. I wonder if we're missing any. So I'm not sure if these events are quite right. They don't quite map to Claude Code. So what I might do is go and grab the event types from Claude Code just to see if we're missing anything here. Okay, so I'm just taking a look at the Claude Code docs. And if you look here, we have this exact same pattern where the agent is emitting events during its life cycle. So we have a bunch of events here that we might want to reference. So pre-tool use, permission request, post-tool use, sub-agent start. So we do not have any of these events at the moment. Stop event. So we might want to steal some of these events. I'm not sure. So this is where we have to make a decision about how we want to design this. I would say the ones I want to take are the pre-tool use, post-tool use, sub-agent start, sub-agent stop, and maybe the terminal event as well. So I think these are the events I want to have. So I'm going to go ahead and make a slight change to our spec. Okay, so now you can see here we're making changes to the architecture document. So this is what our technical design is looking like now. Obviously, it's getting quite complicated. We've got a ton of detail, but you can see here that we've got the pre-tool use, post-tool use, stop, sub-agent start. Okay, so now we've got our architecture. So the next thing we want to do is maybe break this down into tasks. So we have both the requirements and the design, but the next thing we need to do is figure out how we're going to go and implement this and how we're going to give agents the information they need to go and write the code. So what we're going to do, we're going to write another task, we're going to run another task, which is basically going to take the technical architecture and then we're going to break that down into a number of discrete tasks that we can then hand to an agent to execute. So let's say blueprint, plan. So we're going to make a plan, and then we're going to pass in the architecture doc. So what we're doing here, we're giving the agent a prompt that says, go and read the architecture document, and then break that architecture document into a plan that we can give to an agent. So we're going to essentially break this down into a number of tasks that we can do step by step to go and write the code and build this whole thing. So we're going to kind of start with something like the project setup, building the basic agent loop, implementing the tools. So we're going to do this step by step. And by doing that, we're able to review the code at every step. So that allows us to kind of correct if we find mistakes along the way. So let's go and take a look at what those tasks are. So let's go ahead and move this to make it easier to see. And let's switch these windows around so it's easier to see. All right, so we have an implementation plan. So essentially what we have here is 4 phases. So the first phase is to build the runnable skeleton. So this is the basic project setup, like build the UV init, the basic project structure. So initialize the project, that makes sense. And then the next task is to create the CLI entry point for the REPL. This makes sense again. All right, so let's go ahead and implement some of this. So now we've got our plan, we've got our requirements, we've got our architecture, we've got a set of clear tasks that we can now hand off to a coding agent. So what I'm going to do, I'm going to take the blueprint. Okay, I'm just going to go and ask Claude to update task 1. So let's go ahead and implement the first task. All right, so let's see where we get to. Let's implement the first task, which is the project setup. Typically what I would do is I would push these tasks out of Markdown into a linear server so it's easier to manage. But we're just going to go ahead and do it here to make it simple. All right, so it looks like we've completed this first task. So now if you go over here, we should be able to see that we now have our basic project structure. So we've got our pyproject.toml. We've got the virtual environment. We've got our source directory. So this is our basic project. So I think this is good. There's not a lot to say here. So I think now we want to move on to the next task. Okay. It's worth noting here, we're being very fast and loose in terms of the development process here. We're not using Git to save our work. Because this is just a demo, I'm going to go as fast as possible. But obviously, if you were to do this maybe in a real project, you'd want to stop at each of these task breakpoints, review the code, make sure everything is fine, iterate and improve the code, and then commit those changes before you move on to the next task. So that if anything goes wrong in the next task, you can kind of roll those things back. But I'm going to keep it very fast here. What's great here is Claude is now writing a bunch of tests. And you can see here we now have the main agent loop. So the first thing we want to do is take a look at the agent code itself. So this is the basic agent loop. And when you think about coding agents like Claude Code or any of these coding agents in general, or AI agents in general as well, the loop is generally pretty simple. So we have a while loop. So when we run the agent, we just run in a loop. We will essentially invoke the LLM, and then we will see if the LLM wants to call tools. If it does, we'll go and execute the tools ourselves and then feed that information back to the LLM. And then we'll just kind of continue this cycle until we're done. So I'm just going to check over the code and see if there's anything we need to think about. All right, so this is where we send the requests to the LLM. So we're sending over the message. So the user is going to send a message to the agent. We're then sending that to Claude, the LLM. We've got some abstraction here. So this allows us to then build in other different model providers. So we could add OpenAI later if we wanted to. So we want to test out the events at some point to make sure we're emitting events at all of the right places. Let's take a quick look at the events. So obviously some code we need to go and tidy up here. Let's go and fix that. And then so we have these different events. We've got pre-tool use, which is emitted before a tool is executed. Then we have post-tool use. We have a stop event, which happens once the agent is done with its response. Sub-agent start and sub-agent stop. So exactly what we declared in our spec. And then the event bus is a pretty simple dispatcher. Finally, the system prompt. You are a coding assistant that helps developers with software engineering tasks. This looks fine. We can obviously go and tweak the system prompt later. And then the main.py is just where we initialize the agent and set everything up. So overall, all of this looks fine. So before we move on, what I want to do is just do a code review. So we can type in /review, and we're going to ask the agent to do a code review to get a sense of what's changed. It's trying to do a git diff here. We haven't initialized a git repository, so it's looking through the agent code, and we're trying to spot problems at this stage. Essentially, we're trying to find bugs, and you can see almost every time you do this review cycle, you're going to find a bunch of issues. So the agent rarely gets the code right on the first time. You can see here there's a whole bunch of issues. All right, so now we've fixed all of those issues. What we probably want to go and do now is spin up a terminal, and let's go and see if we can actually use this agent and see where we're at. Okay, so I'm in the terminal, and now we're going to see if we can actually use this. We're going to say, let's just double check we're in the right directory. Say UV run, I think it was nano-agent, and see if this agent actually starts up. All right, cool. So we have the agent running. I think this is obviously a bug. I think this model should be the newest Sonnet version, so we need to change the model to be 4-6. Let's see if we can actually get a response. We may not. Let's see. All right, cool. Okay, so the agent is now responding. This is nice. You can see the thinking trace. So this is really, really useful to be able to see. So we're kind of seeing what the agent is thinking, which is really, really cool. And then you can see here that it's helping us with software engineering tasks. So let's try and list files. So let's see if we can call any tools. So list the files in this directory. In theory, it won't be able to do this because we haven't added any tools. So you can see here there's an error. So this is okay, cool. So there's an error here. Let's go and feed this back in. So there's probably some logic that's broken around the tool calling, presumably. So let's go and fix that. Often these APIs are quite brittle and quite difficult to get right. So let's go and improve this. All right, so switching back into Claude Code, we're going to feed back this error. So when invoking a tool, I see this error. We're going to give it the full stack trace and then see if we can find, or like pinpoint where this error is happening. So again, it's kind of one of the things that's kind of interesting is how often these agents make mistakes. And so how important it is to do a lot of testing and iteration with these coding agents, because they often make a ton of mistakes. You always want to be iterating and never kind of blindly accept the first output, because often they are wrong. All right, so we're going to spin up the coding agent again. So we need to go and fix that model version. So can you list the files in the current directory? So we're kind of trying to invoke a tool call at this point and seeing if the model hallucinates or if it's able to call a tool at this point. It shouldn't be able to. I don't think we've implemented tools at this stage. So, okay, it's given us a response, which is interesting. And okay, you can see that it's listing out the file. So when we ask the agent to list what's in the directory, this is kind of really interesting. It's hallucinating the tool call, which is something that's kind of interesting to watch out for. I don't quite know why it's doing this, but it seems to be hallucinating. There's not a license in this repo. There's not a git ignore. So this is a case where the LLM is actually hallucinating the tool call. So it's something to be really, really mindful of and maybe think about. Okay, so just rerunning the agent, I kind of don't like the look of this UI at all. I think there's just a bunch of issues, especially the splash screen. So what I'm going to do is maybe take a screenshot of Claude Code and see if the agent can more closely match that UI. So this is quite a lazy way to do this, but what I'm doing here is I put in 2 screenshots of Claude Code, and I basically told Claude to go and more closely match the UI of something like Claude Code. It's a lazy way to do it, but it's often a good way to kind of give it the context So let's see if we can kind of more closely match this. Notably, the Claude Code interface is very complicated. We want to keep things relatively simple, but we also want to kind of improve what we currently have. All right, let's boot up the agent one more time. Okay, this is looking a lot cleaner. You can see here now we have this much better splash screen. The model is correct. The current working directory looks really, really cool. Okay, so now we're done with phase one. We've got a good looking terminal UI. It's pretty functional, and we can probably commit our changes at this point. So let's go ahead and click commit. All right, perfect. So now we've finished phase one. We've committed our changes. What I'm going to do is just clear the context. Let's do clear. And we're going to start again, and we're going to move on to phase two. So we're going to say read at, where are we? Tasks. And implement phase two. Start with the first task. So let's go ahead and start working on some more tasks. All right, Claude's being quite eager. It's gone ahead and has implemented all of phase two, all of the tasks in phase two, which is fine. Now it's actually moving on to phase three. So we're just going to let it run. So it's going to run through phase three. And if we go back to our tasks, you'll see that phase three is where we're doing the sub-agents. So this should be fun to test. And phase four is just going to be about testing and making sure we have coverage. So this is all good. And I think at the end of phase four, we're basically done with our MVP. So you can see Claude is now adding the sub-agent logic. And essentially a sub-agent is just a way of the parent agent firing off another agent with a clean context window and a clean set of instructions. That sub-agent will run in the background and then pass the result back to the parent agent. So we're going to be able to have parallel sub-agents with our coding agents. So we're going to be able to do things like, 3 or 4 sub-agents running at the same time on different parts of the code base and then feeding information back to the agent. So this is quite a powerful feature to implement. One thing I want to quickly do while Claude is working on this is maybe make a to-do list. So I'm going to go ahead and create a to-do.md, and we're going to capture a few things. So to-do, I think one of the things I want to do is add logging. So one of the things I want to do is add a logging listener. So add a logging listener. If we don't already implement it, it may already be in the task, but I want to make sure we have a logging listener because that's a really useful feature. We can write the output to a log file, and then we can kind of tail that and kind of see what the agent is actually doing when it's running. This is a really useful feature. And we also want to use the Python logging. So Python logging framework instead of just printing out to the file. All right, Claude is done. So phase three is now done. We should have sub-agents. So I think we definitely want to pause at this point and start testing this out in the terminal. We need to test out the tool calls especially. So we need to see if we can actually execute bash commands. So let's take a look at how this looks in the terminal. All right, so we're back in the terminal. Let's fire up the agent one more time. So we've got the nice splash screen, and now we should be able to say list files in this directory. I typed that wrong, but it should still figure that out. The user wants to list files in the current directory, allow list directory. So this is really good. So now we have the approval. So let's say yes, and then it's dumped that out. So this looks good. All right, cool. So this does actually look correct. Unlike the previous time we asked this question, it's no longer hallucinating. It's calling the tool. Let's see if we can run a bash command. So what is the current time? Run the date command on the host to get it. So we're going to use a bash command here. So the user wants to know the current time. Allow run bash. Let's say yes. Okay, cool. Okay, amazing. So we have a bash tool. We're able to read and hopefully edit files. So we pretty much have the foundation now of an agent that is very close to something like Claude Code in the most minimal sense. So this is looking good. We obviously don't have any of the advanced features of Claude Code, but we now have a basic coding agent that could probably do some interesting tasks. So what might be fun to do here is see if we can do a code review. So we're going to say read the code at, let's do src / nano-agent / agent.py. Let's see if this coding agent can do a code review and do a code review. So let's see if our agent now has the power to do a code review. We need to click allow read file. All right, no such file. Let's see if it reasons about how to do it. List directory. So this is kind of interesting. So now our agent is reasoning through the initial file it couldn't find. Now it's using its reasoning to call lots of tools. So this is really good. It seems to be able to find the file and it's working through this. Looks good. Okay, so we've basically built now a very, very minimal coding agent from scratch that is able to do a code review. So this is really good. This is like kind of where we wanted to get to. There's still quite a few bugs here. We can obviously polish up the UI. That's pretty easy to do, but looks like we have a very basic working coding agent that is able to do code review and presumably able to write code as well. So there's definitely some stuff here with the UI that we need to fix. Okay, so this is really cool. So it's able to see the OBS, which is my recording studio. This is using most of the CPU. So this is a really powerful basic agent. Even though we only wrote a few lines of code, this already is a basic working coding agent that you could use for practical work. So you can run commands on your machine, you can read code, you can do code review, and you can also write code as well. So we have a very basic coding agent. So there's definitely some things we could do here. So in terms of the next stages, we should probably think about tidying up the UI. So I'm going to do another sweep through, tidy up the UI, and see if we can improve this further. Okay, so back into Claude Code. Let's go ahead and save and commit these changes. Let's go ahead and save our work so we've got this stored. And then we should also maybe do another code review to kind of look for bugs and things like that. So let's just review, see if we can find any bugs, and then we should go on to improving the UI. And I think we also have some additional work to do. So if you go back to reference our tasks, we've now completed phase 3, but I believe we've got a phase 4. So let's go and find this. Phase 4 is all about testing and polish. So as you can see, when we did the code review, we found a bunch of issues. So we probably need to fix all of these. I think one of the things we need to do now is a configuration file. So I think one of the things we missed in the original design was the ability to have a config file, because I don't want to be approving all of these tool calls. It's going to get very annoying. And so I think we need a way to, this is going to get really annoying really, really fast. So we need some kind of way to manage the approvals. So I think what we want to go do now is actually, I'm going to quit this. I'm going to go and build a configuration system, because I think that was something we definitely missed in the original requirements. So I made a mistake when I defined the requirements. And this is why, obviously, as you iterate through this process, you realize things as you go along. You can't always know everything up front. But one of the key things that I missed during the initial design was the ability to have a configuration file. This is pretty much table stakes for these kind of agents. We want to be able to configure the model, and we also want to be able to configure the tools that need approvals. So for example, we don't want to be constantly approving tools. We want some way to skip tool approvals. So let's clear this, let's clear the conversation. And can we add a feature that has a configuration file? So I want the ability to configure the agent. I want the ability to specify the agent model. And I also want to be able to specify the tool calls. I want to be able to specify which tools are enabled and whether the tools need approval. Can you generate a YAML-based configuration system and wire up the config within the agent? So I'm not actually going to bother speccing this out. I think it's a relatively small change. So I'm just going to kind of vibe it and let Claude figure it out. Obviously, if you're going to build out a coding agent like this, there's a whole bunch of decisions you need to make about how a user should configure this, where the configuration file lives, how you do configuration overrides. Obviously, you can take this a lot further. We're trying to just build the most basic MVP coding agent here, but you can see how easy it would be to add and extend functionality here. Now you have the basic agent. You could very easily add additional tools. You could add all kinds of complexity here and interesting features. So when you can write your own coding agents, you have the ability to build basically whatever you want. So you can bake in different workflows. You can bake in different tools that aren't available in things like Claude Code. So it's really powerful to be able to build these things yourself. And it's really, really a useful exercise for learning how these coding agents work in general. So it looks like this is what Claude is coming up with. This is the configuration file format that it's got. I don't think we should be able to override the system prompt. I think that's a huge risk. And I don't think we should be able to override or disable the core tools. So this is probably a mistake on my part when I specified the requirements, but we might want to have so rather than this, what we probably want is something more like Claude Code, where we have the ability to override approvals. So I think I'll maybe change this to say something like dangerously skip permissions with Claude, where I'm not going to ask for tool approval, rather than have a mechanism where we have to configure every tool individually. I think that's going to get quite annoying. And we definitely want to remove this system prompt from the configuration as well. All right, so we've built out this. So the first thing we need to do is get a nano-agent configuration file. And we also need to go and fix some of those issues I mentioned. So can you fix the agent configuration so that rather than approving or disabling individual tools, we just have one flag, which is the ability to skip tool approval? And can you also remove the ability to configure the system prompt? We don't want to configure that via configuration because that would be dangerous. The system prompt should be hard-coded. Can you go and fix those issues? All right, so we fixed up those config changes. Let's take a look, see what it looks like. Let's take a look at the config. Okay, we still have this disable. So we have a skip approval, so this is going to be useful, but we also have this tool, enable or disable individual tools. Let's get rid of this. Let's get rid of this functionality. So I keep harping on the UI, but I want to get it kind of polished before we finish up. So let's see if we can finish this up more. So I'm going to upload another screenshot of Claude Code. Okay. Can you more closely match the following UI? Currently, when we have tool call execution, we see a massive output and it's kind of hard to read. Can you follow a UI that is much closer to the screenshot below? We should be able to see the tools that are being invoked. So we want to be able to see the tool call, the name of the tool being invoked, and a truncated or minimal set of parameters being passed. And can you also show us the thinking as well? So have a look at this screenshot below and see if you can improve the UI in any way. All right, so I'm just really being lazy here and just asking Claude to figure it out. But let's kind of experiment and see if we can improve the UI a bit just before we finish up. Okay, so now we're going to try something really interesting, which is to use the coding agent we just built to see if it can fix an issue in itself. So what we're going to do, one of the features I wanted to add was a logging listener that will listen for agent events and then log it to file. So we have an audit trail or a log file. Can you implement a logging listener that listens for all events in the agent loop and then logs them to file, use the Python logging framework, and go ahead and implement this change? So what we're trying to do here is to see if the coding agent can fix its own code. So you can see here the tool calls look good. It's reading all of the code, and let's see if it can go and make this change. So let's go ahead and see if the agent did the right thing. It looks like we've written a ton of code. So this is the coding agent we built is writing code for itself. So I think we've kind of reached the point where we have a fully functional coding agent that is able to write code in its own code base. This is crazy. So I found that building an AI coding agent was actually one of the best learning experiences I've had personally in terms of understanding AI agents and how they actually work behind the scenes. Even now, having built an AI coding agent previously, I learned a ton about the architecture of tools like Claude Code, especially around the event loop. I hope you found this video interesting. If you did, please remember to like and subscribe. It helps the channel a ton, and I really appreciate it. Thank you for watching, and I'll see you in the next video.